Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello and welcome to the Tech Lunch Podcast. I'm Nick.
And I'm Ed. And this week we have a special guest. James, introduce yourself.
Hey, I'm James.
All right, and this week we're kind of going to talking about the IT stack, the OT stack, the automation stack, and we're going to start from the bottom level, work our way to the top. We're talking about the ground level process, or better known as the process level that we're talking about in the Purdue model. We're talking about your sensors, your drivers, and your actuators, and your freaking robots. When we're starting to think about that, you talk about, how that data, data that's being utilized at those levels or collected those areas that can be sending that data back up the stack, and how we can get to your main enterprise network back to your MQTT areas and stuff like that, where somebody can take that and translate that to KPIs. So, Ed, when we're talking about the process area, what are you thinking about?
So when I think about the process area, things that come to my mind is all of the data we can capture and using that data as in KPIs and setting up dashboards so we can capture if a sensor is seeing some abnormality, or if a drive is drawing too much current, or if an actuator is not performing like it's supposed to, or if we have a robot that's out there welding a point and it always has an issue at a point, or it has an issue at some place in a coordinate. We can capture that data in real time. We can feed that up the automation stack. We can analyze that data in dashboards for managers where they can make decisions and say, hey, well, maybe when we run this type of unit, we need to run less of this unit till we figure out this problem. So, James, you're new to the show, new to the podcast, and we would like to know from a controls engineer point of view, how could you use these tools?
Well, Ed, I guess from a moderately involved controls engineer perspective, I guess the main thing I'm looking for from upper level systems is the reduction of signal proliferation. And what I mean by that is that we want to bottleneck our communications as much as possible. So we don't want to be writing to every single device we have in here. We don't want to be writing from the top down, from the bottom up, from most of our PLCs straight to an upper level server. We want to try and put a restriction on that as much as possible. And the good thing about some of the new web security and net security standards is that they do introduce nodal architecture in a way that benefits us. So most of our LANs and most of our control nets only are really concerned with talking to one specific server, because if it's done right, we are controlling the data flow through one point. And my imagination is that we're doing that to limit the exposure of any attacks.
Okay. Now, when we're thinking about that, as we move into the, the basic controls area, the batch controls and stuff like that, safety controls, safety nets and whatnot inside the station itself, but the thing is let's kind of backtrack back down to, down to the main level, as we talk about, basic controls and the process levels, we start thinking about preventative maintenance. James, you as a controls engineer, when you start thinking about preventative maintenance, you start thinking about these controls have to be replaced at some point in time. So, if you start thinking about like MQTT, if you have a smart sensor, for example, we know that, a major industry supplier out there, Lensa does support MQTT, but now how can that support help you when you're talking about your basic controls areas and your process areas?
Well, it all really goes back to your main controls philosophy. So we're at an interesting time in history, and that I'm not going to say for the first time, but for the first time on a large scale, have people that really are coming into the industry not from a standard electrical or a standard maintenance or a standard mechanical background, but we have some of these young cats that are coming in that understand computers and understand networking and understand coding. So for the first time, we're really starting to think about how we lay out our systems, and not that we're just patching in whatever we get as we go along, which, to be honest, for even high level guys, is going to be 90% of your work in the controls field, is just figuring out what your maintenance guys have cobbled together over the years. But the way it is going to make my life easier, and that's especially with some of the new SCADA, HMI, MQTT production system, MES hybrids, especially your ignitions coming out, is that we can have a unified communications approach. Lens is a fantastic example. I like a lot of the directions Lens are moving. I think they've got a better approach on Industry 4.0 than, say, some of the big boys, especially Allen Bradley, though you're going to find that I'm pretty biased against them to begin with. But so back to your question, is that it allows me to structure my controls net on a unified concept and not necessarily have to run by the skin of my teeth, have 700 different controls protocols or communications protocols or industrial networking protocols. Because I guess the end message is that, at least in America, in the American market, and as much as it pains me to say, that's going to be your norm. Is most places you walk in are going to have controls net and DNet and maybe Profinet and industrial Ethernet, and it's just going to be a hodgepodge because nobody who understands it put it together. So that's the main benefit, is that someone who actually understands networking and understands computing and understands subsystems has put these together with options that we can unify our controls and communications protocols.
Well, whether you like this system or that system, say A or B, the thing that I took from what you said is that you're looking to optimize the system. You're looking to take legacy systems and incorporate legacy systems into a process where you don't have to bother with these legacy systems. We know that a lot of these plants are going to be using the same equipment for 20 years, maybe 40 years. But here's the caveat. You said an interesting thing before. You was talking about not proliferating a lot of signals. The beauty of MQTT is I can assign topics, and with those topics, I can say, hey, I'm only interested in this. I'm subscribing to only this. Yeah. So now you can build a funnel, and with that funnel can take all of these data points and put these data points into a place, feed it up through the SCADA system, from the SCADA system up to MES, from MES up to the ERP system, and all these systems talk together, not directly. They talk to each other through a MQTT system where basically I have a pool of data. Everybody subscribes to this pool of data. If anything changes, it changes in the pool. So I don't care about current in this application. I care about VIN numbers. So I only want VIN numbers. So you subscribe to what you want. And that is the beauty of MQTT.
Yeah.
That is the beauty of MES and ERP and SCADA systems and the lower levels where we got sensors and HMIs and PLCs. That's the beauty of all these systems tying together.
Yeah, and the thing is, from the IT standpoint, when it comes down to the lower level process and the basic control standpoint, for me, it's easy. It's the taking this data and throwing it into a server and kind of just fighting with it. Not really fighting with it, but kind of making heads or tails of what's going on. And, that kind of takes us for, kind of a loop, because we start talking about, absorbing all that data from the lower level and taking that and throwing that into dashboards, which we were talking about visualizations before, and also, using that data to make educational changes later on, as far as changing our KPIs and also like our purchasing standards. And, but that also goes back to, when we start getting into the clients, the workstations and stuff like that. This is the world that, pretty much I begin to live in from the IT standpoint, is building your client to work on your line. We start talking about that. We start talking about, how do I interact with the technology that's below it? And that means, like white labeling out, different clients and keeping them on the internal automation network, or kind of the cell network, or the zone network, if we like to go that way, inside the firewall. Or we talk about outside the firewall, if I need to communicate to my main network or not. It's just kind of how, how we look at things. But when we start thinking about workstations are kind of one of those things of where it can go from A to Z pretty quickly, because, in that same standpoint, you have the workstation of your team leads, your group leaders, and stuff like that inside that area that are managing their people and looking at their zones along with the maintenance techs. However, then you start getting into the engineering standpoint. We have to have engineering laptops or workstations that have to communicate not just from, the internal network of that station inside that DMZ, that zone inside the firewall, but also outside the firewall when you're talking to outside parties and vendors. So when we start talking about, what is called the Area Supervisory Control Network, or level 2, in this grand scheme of things, we start talking about workstations. So, and James, you come from the control side. When we start talking about workstations, what are you kind of thinking about when you start hearing that, as far as thrown on from the control standpoint?
From the control standpoint, generally, and in most of my experience, we're talking about operator interfaces for planning and steering and marquees. So we're talking about ancillary or add-on purchases to most of my projects. It doesn't present much of a consideration or challenge in most of my work, and honestly, not much of a risk. And I think this is one of the things that you're going to see in the future become a lot more user-friendly and a lot more fleshed out, is the delineation between just traditional controls and some of the more, for lack of a better term, IT-facing aspects of modern computer-based manufacturing.
Yeah.
So
now, hold on. Now, when we start thinking about that, when you're talking about workstations, are you also thinking that you should be thinking about HMIs at that same point in time?
Well, no. Yes and no. See, we're going into controls concepts now, and the way I see the future going, and I'm going to go out a limb and be opinionated here to say for the better, and the correct way is to just blur the line right up between HMIs and what we call marquees and workstations. We need to make these flexible and adaptable and much more user-friendly to your average operator. So I think one of the good things that we're seeing in controls architecture and like I said, the approach of a more computer savvy workforce entering into the manufacturing hardware and a day-to-day manufacturing zone is that we are, especially like I said with ignition and with some of these enhanced and integrated, and I'm doing air quotes here, SCADA platforms, is that we start to merge what we consider traditional HMIs with what we would consider, again, marquees and operator facing and management facing and steering facing, so that we can unite it not only for ease of programming controls packages, but for ease of use by the end user. So let's just go ahead and say it's an operator interface, just like a car. And that's really where we want to go. I think whether the industry knows it or not, whether the world knows it or not, where we want to go with controls is where we've always wanted, and what we've always talked about and has been a big joke in the controls world is plug and play and set it and forget it and turnkey. Those terms are jokes and misnomers in the controls world because no system that you deliver can be this. But I think the approach that can get us the quickest to that is from the top down. So read that to mean from higher level systems, from your SCADA, from your server, from your main data processing and steering down to controls, and minimizing the role of the PLC.
So I would say when we talk about that, the reason we leave those devices or we leave those concepts in different levels is because of what you said earlier. Because of security concerns, now we have to segment the networks. Now we have to have industrial security zones, enterprise security zones, and then we have to have a DMZ. So I totally agree that we should make these things a service in the cloud. However, we should also have internal services or internal clouds that speak from cloud through DMZ to cloud. We may not need the hardware. We may not need 100 HMIs. We may just need a server that runs a service in a cloud, internal cloud, and then we send that to a tablet.
Sort of like a headless workstation.
Headless workstations, tablets.
Z-boxes,
VR.
whatever.
I mean, you just name it. Personal area networks. There are a lot of things you can use to do these things. So you're right. As far as having a PC out on the floor for a HMI, I think that's going to probably be something that will go away. It's something that we can live without because of the way we live today with all the technology. So Nick, what do you think from a cloud point of view, as far as saving money on resources? How do you think that works?
Well, there's a lot of stuff that you can do, especially in that, especially for like the operator interfaces and stuff like that. I can buy more iPads and stuff like that for a cheaper rate than I can buy an entire, HMI set. So, but the thing is what I could do from there is go to a BLE system or Bluetooth, and take that interface. And as you walk by certain areas, it'll pop up on your screen. It'll pop up the HMI just right there on an iPad based off of a BLE network, or a Bluetooth level area network that's communicating to that via a cloud interface. And your cloud's always going to be cheaper than running an on-site network. Always. One, you don't have to worry about the risk. You don't have to worry about anything like that. But also, you start getting into the API configuration. Now you're talking about doing API communication from point A to point B. Now I'm writing all of your code and stuff like that using APIs. which is actually more secure because you're having to use certain tricks of the trade to pull data out of the API using JSON and XML, amongst other things. So it kind of segregates your data even more. And also, when you're talking about like the cloud level stuff, you're talking about virtualization. Inside the virtual realm, you're talking about virtual switching, virtual networking, and stuff like that. So you're segregating your data even at the OS level instead of worrying about segregating your data at the lower end level. So you kind of do all of that beforehand, then you still run through a switch and stuff like that. In a firewall, internal firewall, and also inside your industrial security zone, which kind of brings us to our next topic, or level 3, is the industrial security zone, where there is a firewall or a jump site from that location, from where we go from the operator interface or the HMI or the IT interface to the cell or the zone, back up into the industrial the IDMZ, which is the technical DMZ for the IT network, back into the enterprise zone. So it gives you a no-go zone. However, you can still cross through there using your industrial firewalls, which, you start talking about, the side of the house. We start going into, say, the Siemens side of the house. You start talking about scalance. Your scalance is the entry level to the industrial security zone and into the industrial demilitarization zone through the firewall subset into your enterprise security zones. So, when we start thinking about, level 3, I'm just going to throw this out there. When you start talking about industrial security zone, what do y'all think?
So I'll just jump in just a minute, James, and then we want to get your point of view, because we always want to look from the customer. And from level 0 through 3, we're talking about the customer on the OT level. One of the things that Dick said with security, the big push now is because a lot of the old protocols and legacy systems, that they're just not going away. No matter how much we wish them to go away, in existing plants, they're not going away. But what you can do is do hardening. We can go in and say, cut these services off. We can go in and say, hey, we only want to communicate on these ports and these ports only. There is no FTP communications. We're gonna do things, and then if we connect something to the network is sensitive to things being connected. So IDS systems, IPS systems, things at that level that can detect these things. But we don't want to make the controls guy job hard. So in my opinion, I think what we can do to make things better, or what we can do to make things more productive, is to talk to the guys that actually work on the equipment, talk to the guys that actually program the equipment, and find out from them guys, hey, what works for them? So what works for you?
Well, Ed, I'm going to be blunt here, and it's that, and I know this will probably be echoed for most of your controls engineer, regardless of our level. Security is not a concern for me, and it's not necessarily that it's not a concern for me, but it's not something I'm going to think about on a day-to-day level, and it's simply because security is necessarily something worried about on a higher level. It's your server level. I by virtue of what I do, for better or for worse, and believe me, some days it's the worst, deal with a machine net or a hard-coded LAN. So I think from that perspective, what we can do, and it's these seeds are being planted and they are bearing fruit every day. How long it's going to take industry to catch up to that, your guess is as good as mine. But we really do need to reduce the amount of hardware on machine LANs.
So let me say this. So I know you say that you don't think about security that way, but when we think about thinking security, it's not, hey, I gotta be at this switch looking, hey, what's going through the switch? That's not what the concept is. The concept is enabling the people on the shop floor. So what I mean by enabling people on the shop floor You use something like TIA Portal, and TIA Portal has these tools built into it. It's not even anything you have to do. It's just once you set up the project is encrypted, so no one can mess with the data. The levels are set up in the project, so you don't have to worry about access control. And then the other thing, it monitors everything that changed in that system. So the security is built into these things. Siemens is in the forefront of making these things, and that's what we need. We don't need the guy that's using the tool to go out and make this tool the best and secure thing in the world. We need the people producing the tools to build the security into it, and we just need to educate the people on what to and what not to do. And Nick could probably give you a little bit more another vantage point from his point of view, why we all have to participate in security, just in day-to-day our thinking. It's more of a thinking and doing the right thing.
Yeah, I mean, it's not hitting the button you're not supposed to hit. Answering the email you're not supposed to answer. It's the protection of the internal network. Because if somebody on the shop floor side of the house does something that they're not supposed to do, you now polluted your interior network, your industrial security zone. And the problem is with that, if once you get inside that zone, it's a pretty open area. It's a pretty nasty area because it's older equipment, it's stuff that's vulnerable, stuff that may not be patched all the time, which is, from an IT standpoint, that gives me heartburn. Because I have to think about how am I going to patch the stuff that's on the line that is not being replaced. That the controls engineer screams, say, I want that replaced, but management decides not to. At that point, that's now up at risk. Because if one of those systems gets infected with malware or with ransomware or with even a Trojan for that matter, it can eat through the network into your networks, but it's worse when it gets into like an industrial security standpoint because it starts eating through and encrypting that data and pulling that data out. Next thing you know, now you've got millions of dollars worth of locked equipment that you just can't reduce. And so that like security standpoint from the IT side, that's what we're all about. We think about it from the IT and the OT standpoint. As we cross through the DMZ. Which we consider a DMZ in the industrial world, it's industrial DMZ, where, that's the web no-go zone. We don't bring the web through there. We try not to. That's why most of the HMIs or anything like that you see in any industrial plant, you'll never get the internet. You'll never get anything you need, people can't go watch Netflix on the line, because that's a great way to pollute your network. But we kind of cut it off there, as a safety standpoint, because that's where our patching network is located. We use that patching network to patch everything below it and also everything above it. So that's kind of, where that goes. But then we start transitioning into what is a level 4, which we start getting into the enterprise security zone of the enterprise networks, the IT systems and stuff like that, the control systems. That's when we start getting to the site business planning and logistics networks, which is our level 4 out of all things. Which that is your MES system. It sits on top of your SCADA. That's kind of where we sit, the grand scheme of IT, where we handle that network, the patching and the scanning and stuff like that from that level. So, kind of when we start thinking about that, what do y'all think about when we start thinking about that area?
From a controls perspective, again, the things I'm going to think about is how bottlenecked the information coming to me is going to be. Let's say if we're talking about the auto industry, generally I would be concerned with quality. I'd be concerned with steering. And there may be some other ancillary systems, but what would really impact me on a day-to-day basis is the amount of servers I have to talk to and the quality and size of the data I'm passing through to those. So at an above level, we're talking probably 2 to 3 levels above my PLC net. So let's read that to mean the CPUs that have some hard programming on them, not necessarily my instrumentation net or my robot net. In that sense, most of what a controls engineer would be concerned with would be the method of throughput.
So I would say, here's the big thing. Here's the beauty of MQTT. I'll say it again. I'm going to beat MQTT into the ground until everybody get tired of hearing it and say, oh, I'm going to check out this concept, MQTT.
Yeah, exactly.
This is a system where I can say I have brokers and I have clients. The client is sending information to the broker. The broker he's the traffic light. He's directing everything where it needs to go. Then I have a subscriber. The subscriber say, I only want to know this data. This data and nothing else. And if it doesn't change, don't send it to me. Only send it to me if it changes. I'm looking for 72 degrees. If you don't go above 72 degrees, I don't care. And here's the other beauty of this whole system. Now, I can put this system into Kibana, use Elastic, use Power BI, make dashboards. And you come in every morning and you got a nice, beautiful little dashboard like when you're driving your car to tell you how much gas you got and how fast you're going. Except for it's not telling you how much gas you got and how fast you're going. It's telling you, hey, I had problems here. It was that sensor right there. Excuse me, maintenance. Please go change that sensor. And then, like I said, from that point of view, Nick can probably take us out and wrap up and put a bow on this present.
Yeah. That's when we kind of bounce into the enterprise network. Pretty much your email, your web surfing, all the stuff that is kind of like your intranets, before you get to the internet, inside that realm. So that is, our first level of protection, for the enterprise security networks. That is the layer that has to be penetrated to enter the rest of the network. However, that kind of brings us back to the fact that, security is everybody's responsibility, no matter how you look at it. And one penetration in any of these areas, the entire area is compromised. And it's just not that. It's just the fact that, we have to think about that. We have to get on board that. We have to be, stand behind it. We got to understand that we have 3 levels that we're dealing with here. But, inside that, we have to push for it. And we got to push for the change when it comes down to the MQTT. We must push for the change for when it comes to Industry 4.0. You said it perfect earlier. Your typical controls engineers are going away. You're getting more of your IT engineers now coming in there that are running these systems. And they're not taking jobs from people. They're making other people learn a little bit. So, as we go there, we start getting people that are more concerned about security and understanding that, and changing the way that we do things on the shop floor levels. But, with that, I lead us out. So, hope everybody has a good night, and we'll see you later. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.